And what I've plotted here is the radiation going to space as a function of the thermal frequency. So the room that we're in is full of thermal radiation. We're radiating, you know, the walls are radiating. And if you analyze it, it's got various frequencies. They look roughly what you're looking at now. So to the right of that diagram are high thermal radiation frequencies, and the left are low. And the smooth blue curve is the famous Planck curve that ushered in quantum mechanics. It's in one of the most famous curves in physics. And the black curve is the radiation that you would see coming out to space from satellites, and we have lots of measurements of this. I'll show you some in a minute. And you can see that the black curve is well below the blue curve, so the total radiation going to space is the area under the black curve, the jagged black curve, and it's substantially less than the if you had no blue greenhouse gases, which is the blue curve. But the point I want to make is if you double CO2, the difference is you go from the black curve to the red curve, which I can just barely see from here, but it's a very tiny difference. Very few people realize that if you double CO2, you will only change the radiation to space by about 1%. In this particular case, we say 1.1%. And there's no dispute about this. IPCC had done this calculation before we did. We said 3 watts per square meter. They say 2.8. So they actually, we're actually more pessimistic than they are, but not by very much. So CO2 is not a potent greenhouse gas. It's an impotent greenhouse gas. And let me just, if you say this is somebody's theoretical calculation, let me just show you. If you use these codes to compare what satellites see, here's an example. And on the left are model calculations with the same codes I just showed you. And on the right are satellite observations. There's no adjustment. These are, nobody has tried to fit any curves here. And you can see that you can hardly tell the difference. I would really have to point out which is model and which is observation if I hadn't arranged it in this way. There's a huge amount of interesting physics I won't bore you with. This is at 3 different latitudes on Earth. One is over the Sahara Desert. One's a little further north over the Mediterranean where it's a little bit cooler. In both of those areas, you see there's a big notch due to the presence of CO2 in the atmosphere. CO2 both absorbs and emits, and so in the center of the line, you're seeing emission of CO2 up in the stratosphere, and over at the sides, you're seeing the Earth shining all the way through all the greenhouse gases, the atmospheric window. It's quite interesting to look at Antarctica, which satellites do, where CO2 reverses its role. So CO2 is an anti-greenhouse gas over Antarctica. So CO2 actually it's latitude dependent what it does. So all of this is a lot more complicated than you would suspect listening to talking heads on television.